Hi, my name is Justin Stevens, and this is my blue sky idea for the future of artificial intelligence education. As more people are becoming increasingly aware of the impact that artificial intelligence is having on our daily lives, they're hoping to increase their AI literacy by learning more about the field. However, many internet sources make AI inaccessible for people that do not have a technical background. For example, let's say that someone is hoping to learn knowledge distillation and they look at Wikipedia. And they're met with this very incredibly dense technical page filled with many mathematical equations, logarithms, partial derivatives, and more. I personally love mathematics, but this wouldn't be my preferred introduction since I'd want the intuition of the topic before diving into the technical details. On the Wikipedia page, there might be a standard definition of knowledge distillation, which is taking a larger, more complicated model and transferring the knowledge to a smaller model with similar performance. Let me try to make sense of this definition through the use of an analogy. For this analogy, let's say that we have a student taking a chemistry class with a very dense textbook. As they read through the textbook, they take notes in the forms of flashcards for the key concepts for them to remember later. In this way, they distill the knowledge from a larger, more complicated source of the textbook to a smaller source of the flashcards that's easier for them to remember when studying for exams. We can do the same thing in AI, where we take a big model and distill it into a smaller model that still has the same essential components, but could be a lot cheaper for us to run. Notice that the name also comes from the distillation process in chemistry as well. Using analogies, I'm hoping to answer the question of how do we teach AI topics better to early undergraduates. And my idea is I want to create a database of analogies for AI educators to use in their classes. And by an AI analogy, I mean explaining an AI topic by relating it to concepts that students already understand well, such as hopefully taking notes and studying for exams. And there's a lot of research in the education literature that backs up the use of analogies. One paper shows that analogies help students remember more information and make them better problem solvers. A recent paper showed that analogies for teaching AI in K-12 help students remember more key concepts and also help them keep in mind key ethical considerations. A big benefit is also that the analogies can be personalized so that students from a wide variety of disciplines can understand AI concepts better. And finally, analogies can include visualizations that allow many learners, including myself, to understand concepts better. Let me show you another analogy demonstrating the last two topics, personalization and visualization. And for this, I'm going to explain the k-means clustering algorithm. If you look at a source such as Wikipedia, you would again be met with a very dense technical page. You can gather a few things from this source, such as that k-means is an unsupervised learning algorithm that tries to group similar points together, but let me explain this through an analogy in the education space. Let's say that we have all these student homes and we're trying to place schools so that students will have to travel the least distance to go to school. So we're ultimately trying to find groupings of students or clusters so that all these students in the same cluster will go to the same school. We don't know how to solve this initially, so the k-means clustering algorithm starts out by saying, let's just place 3 schools completely at random, which is shown with these black dots here. Then each student is going to do the logical thing and go to the school closest to their home. And this gives the breakdown of students into 3 groupings, blue, orange, and green. This isn't the best possible grouping, as you'll see, because the average squared distance that a student has to travel is over 9. So how do we make this better? Well, the k-means clustering algorithm says to move each of the schools to be the average point of where all the students are. So for example, we can move the school with the students in blue up and to the right, as is shown there. And we can continue to iterate on this process by continue to update each of the schools to be the average of where all the students are, and we notice that this average square distance continues to go down. And if we iterate on this a couple more times, we will ultimately get to a point where the average square distance is now below 2. So we've went from all the way above 9 to below 2, which is a significant improvement. So the k-means clustering algorithm was able to find these 3 groups of students so that the students do not have to travel very far to go to school. So notice here, through the use of an analogy that is both personalized to educators and involve visualizations, that this concept is hopefully a lot more intuitive to learners. For the next steps of my blue sky idea process, I would love to crowdsource the analogies from AI educators. I would love to have a system for sorting the analogies by various disciplines, complexity levels, and whether or not they include visuals. To even have a system for participants to rate the various analogies that they like the most, such as on Reddit, or we could even have AI generate some of these analogies, or perhaps the graphic for this idea. Thank you so much for your attention. Please feel free to reach out to me with any ideas that you have, and here were some of the references that I was reading when I was proposing this idea. Thank you so much.